We are all here today to discuss about JavaScript, and Nir made a really, really great introduction because he wrote Typescript. So yeah, thank you, Nir. And actually, I'm here to tell you that you should all write Typescript after this talk. So another round of applause for Typescript. We'll discuss a bit about JavaScript, and we'll discuss a bit about types, about static types. We'll see how JavaScript actually made us love programming, how it's easy to get going with projects, it's easy to build prototypes, small projects, but how it also gets somehow in your way when you're building big apps with big domain models, with hundreds of thousands of lines of code. So first, we will discuss a bit about JavaScript. Let's start with a simple question. Who here has ever used JavaScript before? Come on, there are a few. Great, that's great. It means that you'll know what I'll be talking about. So JavaScript, if there are some of you who don't know about it, JavaScript is this dynamic language which was built in the 90s it was built to be used by the browser to script a bit of HTML pages, but it has come so far that nowadays we are using it for everything, and I mean everything. Here, we are still using it for the web, because yeah, the web is still there and it will be for a long time, but we no longer have just simple HTML pages. We have those big apps, single-page apps, hundreds of thousands of lines of code with thousands, maybe hundreds of developers working on them. So they have to really perform well, they have to be maintained over the course of several years, and this is where JavaScript gets a bit in the way. Then we have the server. We have Node.js, which is a really great technology, and is really, really popular nowadays. Node.js and with its package manager mostly. Then we have mobile, we have desktop, we have embedded devices. All those areas are areas where JavaScript was a stranger a few years ago, but now it's really popular and it's starting to grow. And then there's teaching. Now, teaching is not actually a programming area, but it's one of the most important ones. You see, if something is trending now in universities or between beginner programmers, it will be even more important in a few years, because it basically sets the trend for future programmers. And this is important. Just a quick mention, Stanford, I think it's Stanford, just replaced their course, their computer science introductory course from Java to JavaScript. So this is a big step in this direction. Okay, but you cannot have programs without a few popular projects. This is GitHub. I'm sure you all know about GitHub, and those are the top 5 projects if you rank them by the number of stars. Can you count how many of them are built using JavaScript? I will do it for you. It's 5, yeah. It's a top 5 with 5 projects built using JavaScript. And they are not all programming projects. That's important. I mean, you have React, you have Bootstrap, you have D3.js, all great libraries. But you also have You Don't Know JS, a great book. You should all read it. And the first position is Free Code Camp, which has almost 300,000 stars. A lot more, I mean, really, really a lot more than the others. And Free Code Camp is not even a programming project. It's about teaching. It's about helping beginners learn their way into programming, not only into JavaScript, but into programming itself. But not only beginners use JavaScript. This is the survey from Stack Overflow. I know it may be biased, but this is the survey from 2017. You can look at it online, you can look at the survey for 2016, 2015, and so on, and you will see that in each of those, JavaScript is not only the first one, but by each year that passes, you will see that the percentage of popularity, it actually rises. But let's get a bit more technical here. Here's a little example of code, which basically is really simple. I'm sure you all understand it, but it enhances an idea which will make you think about why we should use types. So this is a simple variable declaration in JavaScript. You can assign a number to it, a string, and then an object to the same variable. You don't have to specify its type, and you don't even have to know it, actually. The runtime will handle that for you. I mean, this is great for beginners. You don't scare them. You get easily going into code. And then you have this. I mean, yeah, that makes sense, right? I mean, who doesn't know that the string multiplied by a number will be a number in the end. But this is true in JavaScript. Moving on. This is the most important part, actually, in a project. This is a little function. I could call this like an interface. And let's make a bit of scenario here. You are working on an old project, like 3 years old. It doesn't have to be much older than that. And you have like a big domain model. You have hundreds of thousands of lines of code written there, and you are assigned to maybe change or use this function, and all you get is this. So you get a function which gets a person and a contact. Is this descriptive enough? Have you ever asked yourself, like, okay, but what happens if you have 7 types of persons? Because in big projects, you might have a domain model with a lot of persons with similar types. What happens if you have different types of contacts? What will happen if you give null, if you give another value? What will happen then in this function? You cannot tell just for looking at its documentation, at its signature, because JavaScript doesn't tell you this. How can we improve it? Yeah, I'd say we should all agree that we as humans are really prone to errors, so we should let the computer do a much better job at this than we do. So as I let the computer do the hard work and just guide JavaScript to do something better. Now, types. I mean, JavaScript has types. Types are there even if you don't specify them. They don't just go away. And they're really, really important because, let's say, this is a simple academic definition, so a particular kind of data item as defined by the values it can take, the programming language used, or the operations that can be performed with it. Blah, 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 really boring. I don't know it by heart. You shouldn't. What's important is that, as I said, types are there even if you don't think about them. So those are the 7 now types you have in JavaScript: Boolean, number, string, undefined, null, object, and now symbol. Those are all the types that the runtime has, but you don't have to tell it what to use. It will figure it out on its own. But will it do so good? Documentation. As I showed you before, documentation is something that's probably missing nowadays from code written in JavaScript. So we have to improve there. How can we improve there? We can improve there by using types. I mean, of course, to that function, someone could have written a bigger comment there. We said, okay, person should be exactly this type. The context should be exactly this type. The function, it does that. But a comment is not really code. So comment has to be maintained separately, and it increases the complexity. It adds a lot of I mean, someone has to maintain that. And at some point, trust me, someone will not maintain that. And you will end up with a different comment and a different function, and it will all get very, very messy. Then we have enforcing. As I said, humans are really, really prone to errors. So we need someone to add a bit of rigor to us, especially as developers. We cannot just be led by ourselves. We have to enforce a couple of rules. And this can easily be avoided in JavaScript because you don't specify types, and everything is really, really dynamic. Code that maybe shouldn't be valid is. But this can be improved. And then we have guidance. JavaScript runtime is actually pretty fast. It's a great virtual machine. But the compiler itself can actually be smarter. I mean, compilers nowadays are really, really smart. They can detect errors which you would not have thought about before. You just have to guide them a bit. Let's see how we can do that. Of course, some people before have thought about this. So they've tried to improve JavaScript. They've tried to use some other languages which compile down to JavaScript. But let's see if they succeeded in a way or other. We have Coffeescript. How many of you have ever used Coffeescript before? Okay, there are a few. Yeah, it was actually a pretty popular option because it added features that were not available in JavaScript before, but it had a funky syntax for people not used to Python, and yeah, well, it tended to remain that way. It also didn't add any rigor because it was still dynamic, and some code was even less readable. Then we have Git. Anyone here programming in Java? Okay, so Google Web Toolkit. So this one, basically, those at Google thought, yeah, we don't like JavaScript, let's use Java. I mean, it should be similar, right? Yeah, well, it's not really. Of course, Java is really strict, statically typed and all. It adds a lot of rigor, but on the web, we have all this asynchronicity, and a lot of stuff happens in the background, a lot of things you don't know exactly, and you need a bit more flexibility than Java has to offer. So there are these two options, which I will talk next about. Those are TypeScript and Flow. Flow is not actually a language, but we'll see that later on. So TypeScript and Flow are actually, let's talk about TypeScript first. TypeScript is a superset of JavaScript. This means that any single code you write in JavaScript is valid TypeScript code. This is really important because first, you have a lot of beginners, you have a lot of people who are used to JavaScript and they love the syntax, they love certain parts of it, and you should definitely make it easier for them to get going with TypeScript. Then you have Flow. Flow is very similar. It's not a language. It's just a static type checker. We'll see later on why. And we have Elm. Yeah, I put it in the corner there, not to punish it, but because I'm not sure how many of you has anyone here ever heard or used Elm before? Great. I knew you were a great crowd, so a bit of applause for you. Okay. Understalls. Who heard about understalls before? I'm sure if you follow any. Okay, so he said this in one of his articles on Medium. He said, I believe all JavaScript libraries, which are intended to be used by thousands of developers, should be written in TypeScript. Can you maybe think about why he said that? I mean, and I'm sure we can scratch libraries. We could say maybe any app that is intended to be used by thousands of developers or developed by hundreds of developers. And we don't need TypeScript. We could use Flow or some other statically typed language. This is really important because of the three things I mentioned earlier, which is document, enforce, and guide. And this can really help us become better developers on the long run. First, let's talk about Flow. As I said, Flow is a static type checker. It's not even a language of its own. It doesn't have a compiler. It's just a checker which needs a little guidance. It was developed by Facebook. So its goal is no runtime errors. This is a pretty big goal nowadays because who here has ever gotten an undefined is not a function? Okay, yeah, that one. That's the things we need to avoid in the future. Then we have TypeScript, which is a language of its own. It comes with complete tooling, its own compiler, its own linter, and it's a superset. So being a language has a few advantages over being just a checker. You can add features to the language. You can add abstract classes. You can add decorators. Really, really good features for object-oriented programming. Let's see a few examples here. This is a code written using Flow. So, I mean, if you've paid attention to Nir's talk earlier, you will see that you have type annotations there, like name should be a string. You just tell the compiler or the checker, yeah, well, name should be a string. Then you have talk, a method here in the person class, which takes another person and returns a string. And we have there an error, because I wanted to show you how an error looks like in Flow and what happens there. So basically, you just write this code, and you say, yeah, well, this should run just fine. And when you hit save and run the flow checker, you will see that, okay, but yeah, you returned there a number. I was expecting a string. Yeah, this is one thing. It really helps. Then we have the same code in TypeScript. And I mean the same code because it's literally the same code. The only difference here is the error and the fact that this code will be then compiled by the TypeScript compiler. The error is similar. It's just a different syntax. Now, getting a bit more technical here, let's say you wanted Mary to talk to, let's go back a bit. If you take a look at this function, talk takes a person. Now, a person, both in Flow and in TypeScript, you can enforce the compiler to say, yeah, well, if I say it's a person, it's a person. I mean, it cannot be null, for example. So it cannot be null. You need it to take a person. So here, let's say I pass Tom, which is null. If you take a look here, what will Flow do? It will tell me, yeah, well, null is incompatible with person, because null is not a person. We have the same thing in TypeScript, again. And here are a few companies and projects which use TypeScript or Flow. I mean, those actually, I think, are all of those are using TypeScript. I think you've read, there is a great article on Medium, I think, Alex, you posted it, about Slack switching to TypeScript. Yep, so Slack is switching to TypeScript with its code base because they have a really, really big app and they need to enforce some rules there. Then we have Asana, we have Ionic, of course Angular. Angular made TypeScript really popular, and thanks for that. And a few more. But let's see its limitations. So of course, we have static type checking. We have, I'm not sure, how many things can you check at compile time? Sure, you have synchronous stuff, you have method calls, you have assignments, but as I said, in the front end especially, a lot of things happen asynchronously, so you may not know everything. You have asynchronous requests, you have requests to the server, you have a lot of stuff. You have form validation, for example, and you cannot know for sure if anything at runtime will be checked by your static type checker. So we need something more. That's why we have flow runtime. Of course, this is in pretty early stage. It used to be called differently. Now it's called flow runtime. And when compile time checking is not enough. This is really important. Let's see what happens here. This is valid TypeScript, and this is valid flow code, actually. But flow runtime doesn't only work with flow, it also works with TypeScript. What happens here, I have the same code, and I will run it to the flow runtime compiler, and I will get this. What happens is that the type that was earlier, called thing, is now a type build with flow runtime. It adds a little constraints to the code. So at runtime, when I run thing.assert there, this is all compiled by the compiler. You don't have to write any of this. When I write assert there, it will throw an error if that object does not respect the structure we just gave it. So this is really, really important. It has the complete type system compatible with flow syntax. And there are already tools available, and I think there's an integration with MobX, if anyone fancies that. Moving on. The last thing we'll discuss here is Elm. I'm pretty happy that a lot of you guys have used it or have at least tried it. But let's just begin by a little code example here. For those of you who have never used any functional language before, this will be pretty, how could I say this, pretty strange. So Elm is a purely functional language. You just have functions, which all of them are pure. You have types, of course, and it's really, really strict. So let's see how an error looks in Elm. An error looks like this, really descriptive. It will tell you the line, it will tell you what it expected in a beautiful way. It can even suggest types you didn't know about. If you put a wrong return type somewhere, it will suggest that, well, your function returns a number, but you said it should return a string, so choose one of those. This is great. This is really great. And they actually have no runtime errors, which is even better. They also have runtime checking for types. All those types which are already there in the runtime are 100% safe, and all those things which come from JavaScript are also 100% safe because they have to pass through a converter before they get into Elm. So this is really important. Having no runtime errors is really important. Of course, the learning curve is pretty steep here, so if you're not familiar with it, I say you should get familiar with it. Overall, I think it's really important to remember that for small projects, for just learning how to code, we should use JavaScript. We should stick to the basics. We should first learn how to code before. We should first learn how to walk before we learn how to run, for example. So first learn JavaScript, learn it well. But when you are developing a bigger application, please use TypeScript. It will help you, and it will help any other developer which will use it in the future. Thank you. Okay, let's see the questions. Would you recommend adding types to an existing code base which is rather large? Yes, actually, I'd say you should add types, and it really helps that both Flow and TypeScript are really easy to get on with. So maybe with Flow, you can just tell it to check a file even if it has no type annotations, and it will still catch some errors there. This happens also with TypeScript. You can do the same. you can enforce a few things. I mean, you just have to add a config file there, and it's all pretty straightforward. Okay, next. Can TypeScript get you a date? Yeah, well, of course. I mean, who doesn't like writing functions, right? Did you have culture clash or resistance in your team as you adopted TypeScript? Well, actually, no. No, but that's because of my background. It might not apply to you. And because in my team, a lot of guys used Java before. They were used already to the strictness and the statically typed, which we have there. But if you, let's say like this, if your team only worked with dynamic languages, they might feel a little resistant towards TypeScript and towards static types, but they will get on with it easily. Okay, how about junior devs? Would it be wise for them to start with strongly types from the beginning? How afraid are they of programming, actually? That's the greater question. Do they like it? Do they enjoy writing functions in JavaScript? That's great. They should. I mean, as I said, types are already there. They cannot be. You cannot program without types. So why not learn them? Why not learn them from the beginning? I mean, if you had a few experiences with coding, you can gently introduce types into the equation. Yeah, I'm sure it would have been at least maintainable. Maybe we'll have it today. Why TypeScript and not flow type? I mean, no, there's no reason. Why I would choose TypeScript actually is because it has a bit better tooling. There are more types available for existing libraries, and a lot more companies are using it already. So you have great examples. And one more reason actually is that the TypeScript compiler is built using TypeScript. So the guys are using TypeScript to build the TypeScript language, which is pretty great because they're using their own language to their own advantage. What about Elm? Yeah, well, Elm is a totally different world. Elm is purely functional, is one of a few languages which can brag about this, so it's really great. In big projects, it has an extraordinary advantage because it can actually be integrated into existing projects. So you can just add, I'm not sure, let's say you have a form which you need a lot of things to do there, and you want to add Elm there. You can just do that. You can just integrate Elm into a part of your app, and everything that will be inside will be safe. So you will not get any errors from Elm. You may only get errors from your JavaScript part. I'd say if you want to learn functional languages, yes, you should definitely start by learning Elm. At least look at the syntax, see why some decisions have been taken instead of others, and I'm sure you will reach to a conclusion which will suit your project. Great, yeah, but you don't use strict, so okay. So what's your take on statically typed types alternatives? Yeah, well, I've already talked about Elm. With ReasonML, honestly, I don't have any experience, so I cannot say anything about it. How do you convert a number to a string in TypeScript? Well, in TypeScript, if you define something that it's a number, you cannot convert it to a string. You can, if you assign it to a string, you have a few functions there. You can just call to string. There are a few ways to do this actually. But you don't convert exactly the same number. You just create a new variable, which is now a string. Is there an Elm corner outside? No, but we'll make one. There will be. How can you easily debug that? Yeah, this is a great question, actually. Chrome, and I'm sure other browsers as well, have support for TypeScript in the browser. So because TypeScript, when it compiles, it can generate those mapping files. So you just map your JavaScript code to the declaration files with TypeScript. So basically, you will have your TypeScript code in your browser, more or less. So you will not see the compiled JavaScript, which is, by the way, is totally humanly readable. This was one of their main points there. So you can debug it pretty easily. You will get your code, which is TypeScript, in your browser as well as your compiled code. So you can do with any of them. is Flow used with React JSX? You can use both Flow and TypeScript with React JSX, basically. I mean, once you have type definitions for something, you can basically throw in TypeScript or Flow, and there are thousands of type definitions for most of the libraries you will ever need. And if there aren't for one of the libraries you use, please add them. I mean, it's an open source project. Doesn't TypeScript make developers become lazy and or less careful with their code base because they rely on this language? I wouldn't say developers become lazy because I think developers are lazy by nature. So you cannot become something you already are. And what happens is that if you work on a small code base, you know every single corner of it, it's fine. But if you work on a larger project, you have access just to one module maybe, then it's no longer fine because maybe sometimes you will get a chance to look at some of the code and you will not understand a thing because of this. How would you memorize a function with TypeScript? The way you do it with JavaScript? So how do you tell when TypeScript is worth the hassle? I'd say if you think the project will be larger, then yes. If not, if it's just a prototype, then sure. But you can add TypeScript to a prototype as well. Why not? Okay, thank you. Thank you for this.